Today we are going to design and assemble a manual expansion valve. We will make each and every part and we will do the assembly at the end with exploded view. Manual expansion valve is situated in the liquid line between the condenser and the inlet of evaporator. The main function of expansion valve release the pressure between the high pressure condensation side and the low pressure evaporation side. The manual valve is manually operated needle valve. The mass flow through it depends on the pressure difference across the valve. The valve used as a supplementary safety valve installed in bypass line. So this is a kind of safety valve. So today those who want to learn basics of SolidWorks, this is a good example. You will learn how to create part and assembly at the end. Even you will see how to create this simple animation. I hope you like it. Now here we have manual expansion valve, full drawing. Now let's read this drawing first, what dimensions and everything. Dimensions are in millimeter. Now thread dimensions are in inches. So whatever thread dimensions, it is in inches. And there are two types of standard. G thread and R thread belongs to BSPP. This is British Standard Pipe Parallel Pipe Thread. And this is BSPT Parallel Tapered Thread. So let's do this. Now we have all items here. Valve, body cover, everything including material, quantity. So first I am going to cover valve body. Now let's check this. Now this is the section view of our main assembly. You will see all the section. Now look, this center one, this is the needle. You just operate and release the pressure from here to here. This is what the purpose of this needle valve. This is mainly a supplementary safety valve. Now let's start with this. Now look, this outer diameter of this valve body 58. Now here we have hexagon shape of flange. See here 48 hexagonal vertical length, and then corner radius R2. Okay, and depth is see 18, overall 92. So let's create first body, then we will cut inside and everything. Activate front plane sketch. Now I am going to activate corner rectangle. Press escape key to out. Now smart dimension. Now overall length of valve is 92. Now height I am going to keep 60. Not 60, this is let's say 30. Okay, 30, because overall diameter we will keep more than 58. Now press and hold shift key, select center point and line and make relation mid point. Now let's make full round body. Activate revolve boss base. Now here I am going to select axis of revolution, select this line, keep end 360 degree. Now we have one solid body. Now let's convert this body into a kind of shape. So again front plane sketch. Now I'm going to draw one center line. Right click or press escape key to out. Again I am going to here start center point arc, and I am going to draw these lines, circular lines. Press escape key to out. Now select the end point of both line, horizontal. Smart dimension. Draw some kind of shape like this. End point. Press escape key to out. Now let's create few important relation. Press and hold shift key. Make this one collinear, not equal. Smart dimension. Now this is going to be 58 divided by 2. Radius 29. 18. Okay, this is also 18. Fine. And I'm going to consider this vertical, this horizontal hexagonal distance 48. So I'm going to keep 48. Now it seems fully defined sketch. Activate fillet. Now here keep parameter 2 mm and let me select these two ends. 1, 2. Say OK, cancel. Now I am going to activate here revolve cut feature. Now axis of revolution, I am going to select this line because this is at center. Just rotate model. And this close profile already selected, and this is going to cut across 360 degree. That's why we keep end condition blind and 360 degree. Say OK. Look what result we achieved. Now select this face, sketch. Now here we need to cut hexagon shape. So activate polygon and connect this point, exit. Now okay, let me draw the distance so that 48. Okay, still we need to define some more relation. Press and hold shift key, select these 2 points. Fine. Extrude cut. Now this time I need to cut outside, not this one. So here we have one option in direction 1. Direction is moving perfect direction. Flip side to cut. Now you will see in preview the outer side going to cut. Now depth you have to define. Make more than this. So I am going to apply here 18, 20. Let's say 20. More than this body. Say OK. See. Let's try to mirror this feature. Select right plane. Mirror feature. Now select from here extrude cut. Now look, you will see the preview. Okay, look, we achieved what we want. Now let's make upper body. You will see upper body 48 millimeter and 52 millimeter, both diameter. 14 this distance and this distance 47 from top. So let's do this first. Okay, either we can create a plane. Okay, let's create a plane. Let's make sense. Activate plane. Top plane 47. Okay. Sketch. Now activate circle. And here I am going to draw 2 circles. 52, enter. And 48, enter. Press escape key to out. Now activate extruded boss base feature. Now here we have 2 profile. First I am going to at the end selected contour and I am going to select inside one. Reverse direction, or I am going to select here up to body and select this body. Now look. Say OK. Again select and activate plane, extrude boss base. Now here this time in selected contour choose outer circle. And here I am going to choose blind. Now this is moving wrong direction. So simply choose reverse. And this depth only 14 millimeter. See? Okay. Look. Click, you will see this option, hide. Now let's make these upper holes. Upper, there is a 40 diameter hole, depth 5 millimeter. This triangle you will see, this triangle shows This is old sign of roughness. The roughness of surface is medium. Okay. Now first depth 5 millimeter. Then there is another depth. Depth is RG7 by 8 inch. This is British standard, British pipe standard. So we will see how going to achieve this. Overall length from here to here 44. If you consider from bottom 44 minus 5 39. Then the thread depth 24 millimeter. And this flat surface at bottom. So let's see how we will achieve. Select this face, sketch. Now activate circle. And here draw one circle. Enter. Now extrude cut. Depth according to drawing shows 5 millimeters. So keep everything as it is. End condition keep blind because this is moving downward direction. See. Go to hole wizard. Here choose straight pipe or straight tap. This one. Now standard British Standard Institution BSI. Now this is going to be a pipe thread. So choose straight pipe tapped hole. Now let's come down and let's see what this is going to be. 7 by 8. In G, the threads are parallel, or you can say cylindrical type of thread. Fine. Now depth. Blind depth is 44 minus 5 39 up to shoulder, and thread depth also you have to mention 24 millimeter according to drawing. Now here in option I am going to choose cosmetic thread, not real thread, with thread call out position, and I am going to select this face and place at this. Press escape key to out and you will see the preview. Say OK. And let me activate option, documents, property, detailing, shaded cosmetic thread. OK. Now I am going to select section view. OK. Look, this is the thread, but we have to close this one. Tapered. We don't need those tapered thing. Select this face, sketch. Now select this outer circle, convert entity, extrude. Now those tapered thing going to start from 39 millimeters. So I am going to start offset 39 millimeter. This is going to start from top. So simply reverse. And here I am going to select reverse up to surface. Now which surface? Up to select this tapered surface. Say OK. Now let's check section view. Fine. Now look, we have a straight bottom. So similarly we will do at all sides. Now let's come to here. Here also we have RG 1 by 2 inch. The thread depth 18. The hole depth 24, and there is a little opening because the pressure from going from here to here. Okay. And the opposite direction same 18 millimeter RG 1 by 2, and the hole depth 25, here 34. Fine. Let's do this. Hole wizard. Everything keeps same. BSI standard, straight pipe tabbed, and here I am going to choose 1 by 2. Now depth is 34, thread depth 18. With thread call out position, select this face and place at center and press escape key to out. Okay. See. Now I have to close this one. So again I am going to select this face, sketch. Now select the outer circle, convert entity, extrude. Now offset, depth is 34, reverse. Now select this face. Let me choose blind, reverse. Okay, change arrow, it should be moved towards this side, up to surface. Now I am going to select this surface. Look, this is important thing, you just note down, say okay. Now this is close from here, but from this side you will see it seems like this. So go to direct editing and find delete faces. In option delete and patch, select this face, delete, say okay, and this is deleted. Even select this face, sketch, convert entity. Again activate line tool, from here to here, exit. Again line tool, from here to this line, exit. Now these close things we are going to delete. Extrude cut. Now select this 1, 2. I just give anything like, let's say 5 millimeter, say okay. Now we have a clear passage. Let's activate hole wizard. The same thing, straight pipe, BSI standard, pipe tapped hole, G1/2, blind. Now this depth is 25 here. Thread depth is same. Position same, select the face, place at center, press escape key to out. Okay. Again this is also tapered face. Let's check section view. Okay. Look, we have a clear passage from here. Now here we have to close, sketch. Now select this circle, activate convert entity, so no need to draw this. Extruded boss base. Okay, let's check direction. Offset, depth 25. Here I am going to choose blind, reverse direction. The arrow also moving opposite side, so change this. Now I am going to select up to surface, and I am going to select this internal tapered surface, so that this covered. Okay. Now I am going to see section view. Okay. Look, we have all side closed. This is what our result. Now comes here, there is a section, you will see detail view C. See, there is a passage, 5 millimeter, 5 millimeter, angle 90, and 4 millimeter from the upper hole. You will just note down here. So let's see how we can do this. Activate front plane. Now let me draw. Okay, before going to draw, let me choose section view. Oh, that's fine. Activate line tool, and I'm going to start with this. Press escape key to out. Okay. Okay, before going that, let me choose center line. This is important, center line. A smart dimension. Now this line dimension 5 millimeter, and the end of this from here 4 millimeter. Okay, this is one in one line, that's fine. It should be at center. The main aim is that. Activate here revolve swept surface. Exit, swept surface. Now here choose circular profile. Now this path already selected. Now here define diameter 5 millimeter. Look, you will see the preview. Rest we will keep as it is. We don't need to do anything else. Say OK. Now look, the passage is created. Now here we need to create a tapered one. So for this, again activate front plane, sketch. I am going to activate line tool and start from the center to connect. Press escape key to out. Smart dimension. This is going to be 2.5. This is going to be 4 millimeter. And let's define the angle. Angle 90 divided by 2. That's fine. This is fully defined sketch. Activate here revolve cut feature. Axis of revolution. If I am going to select this one, direction 1, angle 360 degree, just rotate and you will see this is going to cut 360 degree. Say OK. Look what result we achieve. This is what our main result. Now material is carbon steel, so I am going to right click on edit material, gray cast iron, actually not carbon steel. This is the OK, comes to iron, gray cast iron, apply, close. Now appearance not seems good, so I am going to change this appearance. Edit appearance, and this is the OK. Now let's edit appearance from here also, steel. Now I'm going to change some holes or something like this. Now let's check 1, 2, 3. Brushed steel. OK. Even though these two shift cutout and this cutout, brushed steel. Let's check section view. OK. Now this fine. It looks better. See here. Now let me save this one. In desktop, create new folder. Manual expansion valve. This is part 1, so valve body. Save. Now here next part is valve cover alloy steel. This is our next part, part 2. Now here this triangle shows the roughness is medium for this part. Now let's expand this. Now first we will outer body. So just note down these all dimensions. 8 plus 2, there is a step. 15, 15, then tapered 8 millimeter, then 18. And this diameter 28, outer one, then inner one. Okay, inner one is 21. This whole, there is a one more, this male thread RG7 by 8. So this diameter going to be, according to calculation, is 30.2. Okay, you can check in your internet or you can calculate it. Then this 40 millimeter, then this one 50 millimeter, and this one is shows RG3 by 4. This diameter, if you calculate this diameter in radius, it comes 26.5. 6.44 we will consider 5. Let's do this. Then there is this is hexagon body. You will see the shape. So this is also we are going to cut 50 millimeter. Now activate front plane sketch. Now activate here line tool. Go little inside. Go little taper. Don't create any relation. And connect. Right click, select. Now make this one center line, construction line, so that we will get proper geometry. Now select this one and this line. If you move cursor outside, it will show you diameter. So simply let's apply all the diameter here, 28. This is going to be 30.2. This is for thread, external thread. This is a kind of male conical type of thread. Now this is going to be 28, internal one. Now this one 40. And this one 50. Fine. And the comes upper one 26.5. That's fine. Okay, let's apply dimensions. Select this one, press escape key. This is going to be 2 millimeter. Now distance from here to here 10 millimeter. From here to here 15 millimeter. This is going to be 15. Let's come here. This is going to 8. And the last one, this is also 18 millimeter. Now we have fully defined the sketch. So activate revolve boss base feature, because we want to create a circular body. Now this profile is open just because of this construction line. So system asks, would you like the sketch to be automatically closed? Say yes. By default, system took this center line as an axis of revolution. I want to make a complete solid body, so keep end condition blind and angle 360 degree. Say okay. We have here. Let's first make this one sketch. Activate polygon, create one hexagon, exit, smart dimension. Let's define this vertical length 50. Okay, still not defined, so press and hold shift key, select the center point and center point of this end point, horizontal constraint. Activate extruded cut feature. And I want to cut this all, so I am going to select 20, even need more, 30. Fine, but I want to cut outside, so here choose flip side to cut. Now you will see this side going to cut. See, this is what result we achieved. Now here let's make the internal holes. See, in top side 28 depth and the diameter 20. From bottom there is a small hole 22 diameter, depth 5, and at center there is a, and if you just zoom, go upside, and you will see this is 5 by 8 inch. And this one we considered this for the diameter for this 22.99 we considered for this, or even though let's say 23. So first I am going to make hole. We will cut from here, sketch, activate circle. Now from top side we need to cut 20, enter, feature and activate extruded cut, and from here let's say depth is 28. Okay, hole wizard, straight tap BSI, pipe tapped hole is, and this is going to be 5 by 8. Now depth is 23. Thread depth also same 23. Thread width call out, position. Now select the internal face. Now place at center point. Press escape key to out and let's check. Okay. Now here activate documents property detailing, activate shaded cosmetic thread option. Okay, let's make a hole here, then I'll show you there. Sketch. Now make here hole, diameter it's 22. Enter. Press escape key to out. Extruded cut. Now depth, reverse blind, make inside. Now depth is only 5 millimeter. Now let's apply cosmetic thread. Insert, annotation, cosmetic thread. Now choose standard BSI, straight pipe tapped hole, and let me choose this edge. See, by default system detect this is 3 by 4. Now depth blind up to next, up to this face. Say OK. Again I insert, annotation, cosmetic thread, and this time I am going to select for bottom side. This is selected 7 by 5G. Up to depth is I am going to select blind. This length is 8 millimeter, so keep 8 millimeter. See, okay. Now we already make one cutout. This one, this one. Oh, by default we added right click, delete. Yes. Now there is a sketch, extruded cut. Keep end condition blind, depth 5 millimeter. Say okay. That's fine. Okay, first I am going to apply the material. This is going to be alloy steel. Alloy steel. Apply, close. Now appearance I want to change, so I am going to add one false appearance, then edit color. Okay. Section view. Fine. Now here you will see inside there is a tapered thread, pipe thread. You will say outside also have same. Now let me save this. Now just go upside, manual valve. Valve cover. Let's go to other part. Next part here, nut RG 3 by 4 inch. See, outside dimension of this hexagon 40, depth 23 millimeter. There is a one hole, tape thread hole, RG 3 by 4, and depth is 18, and this corner have chamfer 45 millimeter. Okay, then there is one more hole 12 diameter. and material alloy steel. Here you will see top plane sketch. Now activate hexagon or polygon, you can say. Press escape key to out. Now select this one horizontal. Smart dimension. Now this distance outside to outside 40 millimeter. Extrude. Depth 23 millimeters. So keep end condition mid plane because I want to add chamfer at corner. Select this corner, sketch, activate circle, draw one circle, press escape key to out. Now select this outer edge, hold shift key, this one tangent. See, this is fully defined sketch. Activate extruded cut feature and here choose flip side to cut. Look, angle, how much? 45 degree. Now you will see how this one is going to cut. Say okay. Look, activate mirror. What is the mid plane? Top plane. Feature to cut, directly choose this, or even though you can select from here, you will see the preview at bottom. If you select full preview, it will show you both, but I prefer partial view. Only what happening is going to show you. See, now tapered hole, we will make from bottom. Hole wizard, straight tap, British standard, pipe tapped hole. Now here the hole is 3/4, so select here G 3/4. Depth 18, thread depth also 18, and depth up to shoulder, not up to tip. Position, select this face, back surface, place at center, press escape key to out and you will see the preview. Okay, now again this is a kind of taper. Let's activate documents property, activate shaded cosmetic thread, select this face, sketch, select circle, outer, convert entity, extrude. Now I want to cover those tapered shape, so offset. How much depth? 18, so keep 18. Reverse, even though look, arrow is in wrong direction, so choose reverse. Now choose up to surface, and this depth I am going to select up to this surface. Say okay. See, it is closed. Sketch. Now make hole here, activate circle, place at center, and this is 12 millimeter, enter. Press escape key to out. See, this is fully defined sketch. Extruded cut, keep up to through all. Right click material, edit material. This is also alloy steel. We want to change the color, so edit appearance, and here I am going to apply this green color. Let's save this. This is the nut, RG 3/4. Save. Okay, this is not, they don't want this symbol, so 3/4. Save. Let's go for next part. Now here the fourth part is valve seat alloy steel material. Let's come here. Now look, there is a half section view, rough surface. Now 3 millimeter this upper flange, 18 millimeter from overall. See, arrow to arrow 18, this dotted to dotted 3. Okay, outside 24, then inside hole 12, this one 20, and there is a one chamfer. You will see the shape 2 millimeter. Front plane sketch. Now let me activate line tool, and okay, let's start something like this. Click. Now let me draw one vertical center line. Press escape key to out. Make sure this line, construction line. Now all the lines are vertical, fine. Now click this line, move cursor, and it will show you diameter 24. Okay. Now this outside 20, inside 12. Now let's apply overall length 18. This one 3. Now drawing is still not defined, so select this point and this line. No, we don't want this this point and this point horizontal. Now it looks fully defined sketch. Activate revolve boss base feature, because I want to make circular body. By default, system took this center line as construction line as a axis of revolution, angle 360 degree, because we want complete solid body. Say yes. Now activate, or even though you can click on the corner, you will see this option chamfer. Chamfer type, angle, distance. Come here, chamfer parameters. Here put dimension 2 millimeter, 45 degree. Here we have to select the edge, item to chamfer, say OK. Material, edit material. This is also same, alloy steel, apply, close. Let me false appearance. OK. Let me save this. Part number for valve seat. Let's do next part. Part number 5 is spindle alloy steel SS. Okay, let's check. This is our part. Let's make the bottom one first. 22 diameter, angle 90 degree. Okay, then you will see this dotted line shows this tapered, this 3 millimeter, this tapered also 3 millimeter, 13 millimeter from arrow to arrow, 24 millimeter, and here we have one pipe thread, RG 5 by 8 inch. This diameter, if you calculate in millimeter, it comes around 22.99. Okay, so we will apply this, then we will apply this pipe thread, 12 diameter. This is also bottom one also considered 12 millimeter, length 96 millimeter. Then at bottom there is a circular piece 14 millimeter at length 10 square. Okay, then M8 24 minus 14 10 length is 10 millimeter, M8 machine thread. I am going to activate front plane sketch. Activate here line tool. Okay, little tapered. Match inner one and connect. Right click, select and exit. Okay, let's make important relation. Okay, before going that, let me choose this one as a construction line. Now this angle 90 means 90 divided by 2, 45. Fine. 3 millimeter. Okay, this is also going to be 3 millimeter. Now from this end to this end, this shows 13 millimeter. Now this one 24 millimeter. and the upper one 96 millimeter. Now let's apply this diameter 12. Now this thread diameter or pipe diameter 22.99. This is also 12 and this one 22. Look, our drawing seems fully defined. So activate revolve boss base feature. Now due to this construction line, this is open profile. So we have to close. So system asks you, would you like the sketch to be automatically closed? Say yes. System by default took the center line or construction line as the axis of revolution. We want complete solid body, circular solid body. So here for direction keep blind and angle 360. Say OK. Select this face, sketch. Now here we have a square. So activate center rectangle, 10, enter and click somewhere here, press exit. Now press and hold shift key, select these two lines equal. Let me choose extruded boss base, blind. Now depth is 14 millimeter. Say yes. This is moving in perfect direction. Sketch. Now for M8 I am going to choose 8 millimeter diameter. 8, enter. Extrude. Keep end condition blind and depth is 10 millimeter. Okay. Insert, annotation, cosmetic thread. Now here choose standard ISO, not pipe, machine thread. Let me choose this edge, CM8, up to next. Fine. Let me see thread, documents, property, detailing, activate shaded cosmetic thread. Okay, that's perfect. Right click, edit material. This is alloy SS. We have here, see, alloy steel SS, stainless steel. Apply, close. False appearance. And I'm going to put yellow. Now let me save this one. Manual. You can, if you want to see large icon, see a spindle. Save. We forget to add here thread, pipe thread. So simply insert, annotation, cosmetic thread. Now here is standard. I am going to choose British standard, straight pipe tapped hole, and let me select this edge. You will see by default system took G5/8. Up to next. Say OK. Now save. Now let's move for next part. Next part is part number 6, wing handle, alloy steel, quantity 1. This is the wing handle. You will see we will create first half one. At center there is a circular body, 20 diameter and depth 15. Then this wing 35, 24, R9, and you will observe 2 millimeter from end side. See, 2 millimeter, 2 millimeter, and depth is 15 millimeter, and this end 5 millimeter. So let's create this. First, top plane sketch. Activate circle tool and draw one circle, 20 diameter. Enter. Activate extruded boss base. Now make the thickness 15 millimeter. Say OK. Now let's choose front plane, sketch. Now here I am going to create wing. So create something like this, connect up to this end, move something here, go back to the point and see the line is converted into arc. Click and connect. Press escape key to out. Smart dimension, let's define the distance to 2. From here to center 35, and from here to bottom 24. And this radius 9. Okay, connect this point and you will see make tangent. Now this looks better. Now extrude. Now keep end condition mid plane because I want to flow material in both sides. Now here thickness 10 millimeter and one end 5 millimeter. So say okay, and in another end we have to cut. So activate top plane sketch. Now I'm going to choose here. Let's start with line better. Connect from here to here. And again start from this end to this end to this end to this end. Exit. Let's check this 5 millimeter. From this end to this end 2.5, so that it should be in mid. Okay, extruded cut, isometric view. Now here keep through all reverse direction. First we have to choose close profile 1 2. Let's check from top side. Say okay. Look, now let's activate circular pattern. Here I am going to select this circular edge. Feature, let's select 1 and 2, both feature. You will see the partial preview. Say okay. Look, select top face sketch, activate circular center point rectangle, exit. Now let's apply dimension 10, enter, press escape key to out. Now press and hold shift key, select these two lines, make relation equal. Activate extruded cut feature. Now here choose through all. Okay, fine. Now this already done. Right click on edit material, alloy steel, apply, close. Let's apply from here false color. I'm going to apply red so that it looks better. Okay, save. Now this is part number 6, wing handle. Now here next part is nut, M8 nut, so we directly take from system. Next is bush, AISI 1020 steel. This nut we will take from system. Now this is the bush, 20 outside, inner 12, depth 6 millimeter. Front plane sketch. Let me draw 2 circles, 20 and the inner one 12. Okay, extrude. Now here, okay, let's keep blind. and depth is 6 millimeter. Okay. Now if you want to edit sketch, now here click on edit sketch and here choose top plane, say okay. Now look, this is on top plane, not in front plane. That's perfect. Edit material, AISI 1020 steel, apply, close. And I'm going to add some false color. Okay. Now let me save this as a bush. Now let's start do assembly. Now you will see in section view in assembly there is a body, then inside the body this is the spindle lies at center, and in upper part the valve cover is seated, see here. Then inside there is a bush, part number 8. Then if you come up, this part number 4, valve seat is fixed in this nut, and this bush valve seat is seated in, you will say this one, what we say, valve cover. So let's do one by one. New assembly. Okay. Now first this window open. By default first part always fixed, so I'm going to select body, valve body, open. Now if you want to rotate, you can rotate from here XYZ, but I don't want. I'm just going to open temporary axis or temporary view origin. If I move my cursor over view, it will going to coincide. See, click and see these body fix with origin. Now let me hide. If you right click, see it is asking you float, means this is fixed body, you cannot move this body. Okay. Now let's take the next insert component, next part, valve cover. Now even though this is also, I don't want to remove anything, so just simply place somewhere here, activate mat. Now this thread going to fix with this thread. I am not going to create any relation between this. Select this face and this face. Concentric relation, say okay. Now just move your cursor. So this is going to sit this face in this face. Okay. Now I am going to fix this wall at particular, so I am going to select front plane of body, come down, and front plane of coincident relation. Okay, cancel. Now if you try to rotate, it will not rotate. See, now even though we can edit this also, this is not a big deal. Edit. Now valve cover, delete this, and I want to come down, valve cover, right plane. See, okay, cancel. Now this is perfect. This shape is parallel to this shape. Fine. insert component, third. Now this is align is in a perfect way, so just place. Again insert component, seat, open, place. Now first fix these two. Met. Now first important relation, I am going to select this circular face and this inside circular face. Concentric relation, concentric relation. Now look, this seat going to fix inside this face. Okay. Now this valve seat, this face sit with this face. Coincident relation. Okay. Just move somewhere here. Select this face and this face. Concentric relation. Okay. Now this is also I am trying to fix seat nut. Okay, nut this plane and valve body front plane. Coincide relation. Okay. Now nut is also not going to fixed. Let's import the next part. This is important part, spindle. Okay. Now let's create first concentric relation. So I'm going to choose front view, section view. Okay, those things going to hide, so cancel it. And let me, this is going to fix with this one. So let's hide this body. Now these thread going to match inside this thread. Met. Select this one and this inside thread. Concentric relation. Okay. Now we will create a relation between these two. So let's go to mechanical mat. Screw mat. Now in 5 by 8 inch pipe thread, if you considered in 1 inch there is a 14 thread. So 1 inch means 25.4 divided by 14 thread per inch. So this is the length of minimum 1.81. Okay. Now screw thread distance per revolution 1.81. Fine. Now here we have to choose two faces. So select this internal face and this face. This is important. Say OK. Cancel. Now if you move, not going to move. Okay, for a better understanding, let's fix nut here. Wing nut. Part number 6. Okay. Now we have to directly select this face. Mat. With any face, let's say this face. Coincide. Now select this face, this side face, coincide. Now this is going to sit on this face. Okay. Now let me choose. Now this is fixed with this. Now if I am going to make this one up and down, see, it is going to rotate, means there is a screw relation created. Okay, let's bring body, show. Okay, let's go section view. Fine. Now here I want to create a important relation. Met. Now go to advanced and distance met I want to create. So select this one and this face. Okay. 0 minimum, 10 max. Okay. Say okay. Cancel. Just rotate. Now this is going downward direction, so we have to edit, limit, edit, and here choose flip side dimension. Okay. Now just rotate. See, this is moving upside, and let's check how long this is going to move. Okay, up to, it should not be crossed this thread. This is up to this thread. Okay, fine. Now let me change transparency. Change transparency. Now let's select one edge and move. See, if I am going to move beyond this, we are not going, because it is fixed up to 10 millimeter. This is going to sit at 0 and max move upside only 10 millimeter. See? Okay, fine. Change transparency. Change transparency. Now let me add here one nut. Go to toolbox, add in, and here I am going to select nut, hexagon nut, and this is going to be our nut. Just move, place at this. Okay, 8M8 chamfer, double chamfer, simplified, let's say cosmetic thread. Okay, do you want another one? No, cancel it. But this is only one relation, so I have to create one more relation. This face and this face, coincident relation. Fine. Even though, let's check nut, plane, with wing nut, front plane. Okay, this is going to align. Say okay, cancel, so that it will move along with hide or change transparency. Now let me fix bush. Insert component, bush, open. Now let me hide this all part. Okay, this is going to fix here, so I am going to choose met, inside face, and this select concentric relation, back face and this face. This is going to sit here. Say okay, cancel. Now let me show, but let me change transparency so that we will know where exactly. Okay, If I am going to move, okay, fine. Okay, this is flawless with this. Now if pressure if pressure want to release, so pressure going from this way and valve open, and pressure move from here to here if there is extra pressure. So this is just a kind of safety valve. Then manually move down and close. Change transparency. Now this one going to save manual. Manual expansion valve assembly. Now let's choose exploded view. Now I am going to choose add a step. First I am going to select wing nut, move upper side, here select done. Next choose wing, move upper side, select here done. This time select this one, move upper side, say done. And let's move the body downward side, done. Select this, done. And let me finish this. Done. And let's say washer move upside, done. And select this body, let's down, little down, done. I want to just show only, say okay. Now right click and here collapse and animate collapse. Now look, now here we have selected replay mode loop, so all the operations going, if you reciprocate, it will assemble, dismantle. Cancel. If right click, toolbar, motion study, go to this. Now open, make basic animation. Now let me choose animation wizard. Rotate no, explode. Next, 8-second start condition 0, finish. Again choose here animation wizard, collapse. Next, duration 8, start 8-second, finish. Click calculate. Now just okay. Now look, this is the simple tutorial for the beginners, those who want to start to learn SolidWorks. I hope you like it. Don't forget to share and like our video. And please subscribe our channel for more video and more projects in SolidWorks. Thanks for watching.